Welcome to Mining Now. I'm your host, Jared Downey. Today on the show, we have a part three. It's actually not. Technically, it's a part two on Mining Now, but they have been featured. This is their third time featuring with Crownsman, once on Agriculture Now, second time on Mining Now. We've got Thomas Hörnfeldt, Vice President of Sustainable Business at SSAB. Thomas, welcome to the show. Good to have you on.
Thank you so much.
I think you give away what your company does by your background, but I will get you to just clip for anybody who doesn't know, who is SSAB?
SSAB is a Scandinavian/American steel company. We have operations in Sweden, Finland, in Europe, and we have two plants in the US, one in Iowa and one in Alabama. We are very much a focused steel company insofar that we like to make value-added product. We make steels that last longer or stronger, helping our customers to make their operations more productive, increase their performance, and so on.
Steel's an interesting thing, isn't it? Because everybody knows about it. Everybody's looking at it every day, all the time. But it's one of those things. I said on the last interview is that I used to work in the aluminum side of things with home exterior. And pardon me?
I said, ooh.
Yeah. Well, this is a long time ago. But even in that industry, it was one could look exactly the same as the other. And it was once you started trying to bend it and use it for different applications, it was not the same thing. The when you looked at the specs on it, it was the same. But the product was not the same. It was very different. And steel's a very similar thing, isn't it?
That's correct. I think we make 400 different grades of steel in total or something like that.
400 different grades.
And that's all about what kind of strength do you need, what kind of wear properties, so longevity do you need, what kind of bending properties, etc., etc., etc. It goes on and on and on.
And it's quite a... Sorry, go ahead.
A Brazilian journalist that I talked to once called us a boutique steel mill, and that's not so bad because we're really looking for those small series, hard to make, high quality, high performance niches of the steel market. We're not a bulk producer by any stretch of the imagination.
In mining, sustainability is such a... it's almost an understatement to say it's a major focus now. It is pretty much in every conversation about everything now. And there's some really good reasons for it. Where do you see SSAB landing in that sort of demand now in the mining world?
Well, we help our customers become more sustainable in a couple of different ways. The wear plate, our Hardox brand, the wear steel that we supply into the mining industry is steel that lasts longer. It has a harder surface. In abrasive applications, when you do digging or grinding or whatever, our steels last longer. And if our customers can replace some piece of equipment every 3 years instead of every year, obviously that reduces the carbon footprint of their sourcing operations. But also, we have recently launched our SSAB Zero product, our zero version of the Hardox steel product, which is made without any fossil CO2 emissions whatsoever. So we use clean electricity, wind power, which we source from Mid-American, our power supplier. We use renewable natural gas so that with clean electricity and clean fuels, we can melt recycled scrap into steel without any CO2 emissions. And then we can use fossil-free electricity and fossil-free fuels to roll that into plates for our customers so that we can provide a product that is based on recycled content and which we have converted to new steel without any additional CO2 emissions whatsoever.
Let's talk about our Heavy Industry World Tour brought to you by Savinoy Equipment. Find, market, and sell surplus and used equipment. We are heading to events across North America and Australia and filming episodes on location. Email us at info@crownsman.com to be part of Crownsman's Heavy Industry World Tour. Petro-Canada Lubricants leads the charge with cutting-edge lubricants and greases tailored to deliver outstanding equipment protection under severe loads over extreme temperatures and environments. From surface to underground mining, their products ensure maximum uptime and savings, extending drain intervals and boosting productivity. With Petro-Canada Lubricants by your side, expect not just lubricants, but total solutions designed to keep your operation running efficiently and effectively even in the toughest conditions. Learn more at petrocanadalubricants.com. As heavy machinery specialists for mining, SMS Equipment knows performance, like the performance they achieve together in a partnership dedicated to the success of their mining customers. At SMS Equipment, they're more than machines from trusted brands. They're the people beside you today and every day, bringing industry-leading technology and expertise to your mining operation. Because the right partnership makes everything possible. SMS Equipment, partners in your possibilities. Discover what's possible at smsequipment.com. Did you know cementitious binders can be responsible for up to 70% of the total GHG footprint of mine backfilling processes? Now you can replace up to 50% of the binder in your mine backfill operations with Graybond, Graymont's new low-carbon cementitious binder. This lime-based alternative binder maintains a 40 to 70% lower GHG footprint compared to typical cement and can adapt to varying mine conditions without compromising performance. Learn more about Graybond at graybond.com.
I do find sometimes with this, when it's the sustainable conversations get going, sometimes there's the assumption that people know what the opposite was. So can we back up? Let's go. I don't know how far back. Maybe we don't need to go 200 years back, but maybe 50 years back, 30 years back, sort of thing. What is the standard production process and power supply for steelmaking?
Well, the embarrassing thing is that we can go 800 years back if we want to. The blast furnace that is typically used to convert iron ore to steel was invented in 1300 something. But we can actually go 800 years back if we want to. The blast furnace that is traditionally used to make steel from iron ore was invented in 1300 something, and it has basically looked the same ever since. And that is also the reason that the steel industry today stands for somewhere between 7 and 9% of the global CO2 emissions. And that's not necessarily because we are bad at what we're doing, but the raw material that we're using, iron ore, is pretty much iron oxide. It's oxygen and it's iron. And in order to get to the iron, we need to remove the oxygen. And since the blast furnace was invented, that has been done with carbon, today in the form of coke. And what happens then is that the oxygen in the iron ore moves to carbon and forms carbon dioxide, CO2, as a byproduct. And we're left with the iron, which is exactly what we want. But this also means that for every ton of iron that you make with this traditional process, you get at least 1.5 tons of CO2. That's a chemical fact. That's part of the deal. You can't really do much about it. You can mess it up a bit more, but at SSAB, we have for a long time been very close to this lower limit, what is even theoretically possible with today's technology.
I just want to clarify another thing. Would that be the same with recycling? Like if you get a recycled steel, does it have to go through a similar, because it gets back to get broken down again then?
No.
No.
That is very much a better way of doing things. When you recycle steel, you put it in a huge bucket, pretty much, called an electric arc furnace, and you use electricity to melt that down to liquid form. And the great thing with this is that when you do that, you really break also the recycled material into atomic level. You really create a virgin material also from recycled content. So as opposed to many other materials, there is no aging in steel. Once you have dug up an iron atom from the ground and turn it into steel, you can basically recycle it forever. And this is a much more sustainable way of doing things. The only thing is that there isn't enough scrap in the world to do this for all steel. So you need to have both, basically.
I was going to say it's sustainable but not scalable at the level of new steel.
Exactly. The recycling rate of steel is quite high. It's 85-90%, a little depending on where you are in the world. But since the steel consumption globally is increasing all the time, the recycled steel can't really keep up. The steel consumption in the world has almost tripled from the start of this century, from around 750 million tons per year in the year 2000 to close to 1.9 billion last year. And that is the reason that all the recycled steel in the world can only cover around 25-30% of the global steel demand today.
For almost 30 years, SureStrike International has been delivering high-quality hydraulic impact hammers. Whether you are in aggregate, mining, or industrial applications, they help provide superior output, process flexibility, and remarkable economics in your front-end processing. With hammers ranging from 25,000 to a staggering 150,000 foot-pound of striking force, SureStrike has the perfect solution for any application. It's time to optimize your front-end processing with SureStrike International. To learn more, visit them at SureStrikeInternational.com. Who is Savona Equipment? Savona Equipment Limited is a buyer and seller of new, used, and refurbished industrial equipment with a focus on mining and construction. They find, market, and sell surplus and used equipment. Does the equipment need work? They can refurbish. Is there something you can't find? They source those hard-to-find items. Selling equipment? They buy, consign, and broker equipment and asset packages. Need equipment moved? Savona Equipment manages logistics for worldwide delivery. Surface and underground ore processing, concentrating and refining plants and equipment, power generation and electrical, pump, material handling, alluvial placer gold mining, recycling, and much more. If you need to buy, sell, find, refurbish, or move equipment, you need Savona Equipment. Savona Equipment, more equipment every day. Visit them at savonaequipment.com. In heavy machinery, uptime is crucial. Meeting productivity demands with less downtime requires top-notch lubrication. The SKF Lincoln SL6 metering device is built to excel. With a proven design, it handles even the toughest conditions, ensuring reliable performance with extreme pressure greases. This automatic lubrication system reduces maintenance, cuts grease consumption, and extends component life. Plus, its advanced sealing technology minimizes leakage risks. For those who demand reliability, the SKF Lincoln SL6 delivers superior lubrication. Keep your machines running smoothly. Visit skf.com/lubrication to learn more.
This is a great explanation. Now, jumping into, can you dig into a little bit more? So now you're saying there's actually a chart here. So you're powering it differently, and the release ends up being H2O. Is what I see on this chart. Can you walk us through what I'm I don't know if you have that chart in front of you, but can you actually walk us through what we're looking at here?
Yes. What you're looking at now is our hybrid concept for turning iron ore into iron without those CO2 emissions that I was just describing. So what we're doing is that we're exposing iron ore not to carbon, but to hydrogen. And what happens then is that the oxygen in the iron ore moves not to carbon forming CO2, but to hydrogen forming H2O, also known as water, as a byproduct instead. And furthermore, we can use the fact that we have in both Sweden and Finland, where we are iron ore based, a virtually CO2-free power grid. So we can use clean electricity to make hydrogen out of water with electrolysis, hydrogen that we put into our processes, and then we get the water back as a byproduct. So we're not really consuming water, we're just borrowing it for a short period of time to lure the oxygen out of the iron ore.
A question that sort of comes to my mind that I don't think you can avoid is that we're 2024 now. A lot of the technology within this has been around. What's sort of what was the stopper for doing this? And not, I don't just mean SSAB, I mean other companies as well, other steel manufacturers. What is the challenge of doing? Was it the technology? Was it just not access to a clean grid that would actually give that kind of power? What were some of the hindrances from implementing something like this?
I think traditionally, to be honest, if it ain't broken, don't fix it. I mean, CO2 emissions weren't a big deal until 10, 15 years ago. We launched this initiative in 2016, and then we were quite early, actually. And there were a lot of doubt in the industry, would this work or not? Would it be better to look at carbon capture or something like that? But now we're doing this in pilot scale. We have a plant up and running, a research facility that does this, like I said, on a small scale, but in an industrial environment. And we're very, very happy with the results so far. We know that the steels that we produce in the future will have at least the same properties as what we do today, just with the added value of being made without any fossil CO2 emissions.
What is the urgency of this? And of course, there's the obvious, the environmental side, but I'm talking more about government pressure, your clients that are actually asking for supply chains with lower emissions. what is the pressure, and how are they sort of approaching it? What level of urgency do you feel coming from both the regulatory side and from the sector?
I think we can see both. If we start at the regulatory side, we do see that we have different kinds of penalties or taxes or charges for CO2 emissions these days. In Europe, we have an emission trading system. We can see similar mechanisms being implemented in many countries around the world. And I think we can see more or less the same development globally, but we are at different stages and different paces maybe, but the development goes in the same direction, certainly. So there are those kind of mechanisms coming, but I think maybe more importantly, many companies are committed to reducing their own carbon footprint, because there is, again, a little depending on where you are in the world, also a consumer pressure and a consumer demand for products with a reduced climate impact or carbon footprint, or what you want to call it. I think maybe the most obvious example right now is passenger cars, where we are starting to get rid of tailpipe emissions. And once we don't have those, the carbon footprint of a vehicle is pretty much related to the materials that it's
right.
And I think there is also quite a lot of awareness out there. There has been a lot of discussions, especially about hybrid cars. How environmentally friendly are they actually, considering conflict minerals and rare earth metals and those kind of things that are involved? So I think that once you make it transparent and once the consumer knows what the options are, there is certainly a demand for it.
Right.
We can see similar things in the construction sector. For example, we can see that buildings these days are using less and less energy for heating and cooling and so on. And then again, the major carbon footprint of a building will be related to the materials that are used in building it. And where concrete, for example, has some challenges as well. So those are maybe the two most obvious examples.
Yeah, it's so you met it's just quickly interesting though you're mentioning concrete, because we've had on the concrete side we have a company like Graymont who's introducing Gray Bond, which is lime. Going back, it's essentially a version of what Romans used to use for their buildings that are still standing, and the reduction in weight and what it takes to produce them it's similar to what you're talking about. So all of a sudden you've got steel and concrete coming into the market that it's not just a little drop, it's a huge, like with what you're producing in comparison. Well, you're not producing CO2 with the production. It's just you're just eliminating it. So one thing I wanted to ask though is on I mean, when you say boutique, it's not boutique maybe the way people would typically use the word, because you're everywhere. But I understand what you mean. It's specialty, like your Hardox line and that. So even for you though, at a scalable level, what is the future of this? Can it be 100% of the plants in the production? What do you sort of look at it in a sort of real world application?
So to summarize, we have two ways of making steel without CO2 emissions. We have the melting of scrap with clean steel and clean fuels that we talked about in the beginning, our SSAB Zero product, which is available also for our Hardox line right now. And then we have this hydrogen-based technology, which we are in the process of scaling up right now. We are already in 2 years from now closing down one of our blast furnaces in order to reduce our CO2 emissions.
Is this the hybrid? Is it called hybrid technology? Is that
correct?
Okay.
Correct. It stands for Hydrogen Breakthrough Iron Making Technology. We're very humble people in Sweden. And then in 2028, we will close down the next blast furnace-based operation that we have in northern Sweden. And the plan is that by 2030, we will be closing down the last conventional blast furnace that SSAB has. We become a largely fossil-free steel company, probably the first one in the world around 2030.
Oh, you have no idea what I would give to be in those leadership discussions while those decisions were taking place, because I imagine it got to be quite lively.
I can imagine. And I have to give a lot of credit to our board, who has been making a very bold decision and a very clear direction to us as a company.
What do you think has been...
By the way, also is interesting from a corporate citizenship point of view. We see that we are also in the process of changing the image of the steel industry, which is traditionally something, relatively dirty. But we are attracting a lot of young people, people that want to join a company that is actually in the process of changing the way we do things in this world.
You're making my job very easier, because you're touching on topics that I want to get to, and it's perfect. So with that's what I was asking. Are you noticing a shift in just the attraction to the industry all of a sudden? We're seeing, I mean, we're on mining now, so we're seeing a similar thing happening in mining, where that it's almost becoming like a technology industry. And so all of a sudden it's a huge attraction, especially to people around the world who are coming from all these different countries, to go, oh, I could be in this industry and have all the technology skill sets. Are you seeing a similar shift in the steel industry, or just for SSAB in particular?
Yeah, definitely. And it's working both internally and externally. I remember that, like I said, we launched this concept, or this plan rather, in 2016, and we're saying we're going to go fossil-free. We don't know exactly how, but this is what we are going to do. And it's not exactly like saying we're going to put a man on the moon before the end of this decade, but it's something similar. It's a vision. Everybody knows where we're heading.
Right.
And that energizes people, both inside and outside the company. And now when we have become more tangible, more clear, we have a clean outline of what we want to do, like I said, we can really see that attracts a lot of people. We have never been getting so many spontaneous applications from universities as we do today.
Wow, that's really exciting to hear. You talk about like that corporate relation and that public relation. What do you think the company has done well in just in communicating? I mean, just being on this show, right? Doing it, not just a little blurb or 30-second, but actually walking through it. What are some of the other ways the company has got their message out and communicated it so that you're attracting these, new talent, sort of changing the way that people look at the industry?
I think that one thing that we have done right is that we've been communicating a lot. I mean, the traditional way when you're developing something is that you keep it really, really secret, and then 8 years later you have a big bang and you hope that it works. And we've done this the opposite way. We said, okay, this is what we want to do. We're not quite sure, but now we're going to do a feasibility study. That's what we said in 2016. In 2018, we released the feasibility study and say, hey, this seems promising. We're going to go forward with this. We're at the UN Climate Summit in New York in 2019. Then we say, hey, this is happening. We're going to build a pilot plant, and guess what? This will be commercially available somewhere between 2026 and 2030. And because we have all these communication points, we have been getting the message out there in a very clear way, and that has generated a lot of interest also from our existing customers. We have been creating what we call a fossil-free partnership program with a lot of our customers, where we today work on increasing awareness about this. You can see at the Mine Expo, for example, both Epiroc and Sandvik were exhibiting products using our emission-free steels, so that we together can showcase what the future is going to look like already today. And this also means that we together plan how are we going to make this transition together in order to get these into commercial operations and commercial products in a swift changeover as more and more of these volumes become available.
I want to go back to, I want to ask a little something about the hybrid system. But actually, no, I want to stick with this for just a second. would you see a point, going back to the regulatory side, would there be a point, and I'm not saying, I'm not trying to pick a side on it, but would there be a stage, do you think, where this would be demanded of steel? Like if it's landing in places like the US or Canada or Germany or wherever it's going to, where they would say this is a requirement of the steel being used in the manufacturing process, or even on a whole other scale, or on imports coming in? Is that, and I'm not talking about next year, I'm saying, is that if the technology is there and it's doable, is it scalable at that level, or is this stay in sort of that particular types of steel that are going to be used?
No, it is certainly scalable, and we have also very clearly said that once we have this technology up and running and once it's stable, it is certainly something that we want to share with the world. This is something that the steel industry needs globally. We need to do things in a new way. So that is something that we're very committed to. I think over time, there will certainly be developments where either you will price CO2 emissions so high that conventional steelmaking becomes uncompetitive, or you would put so stringent demands on the carbon footprint of the end product that you can't use conventional steels. And this is something that we're seeing at many of our customers today. One of those fossil-free partners is Mercedes, for example, with plants both in the US and in Europe. And they have something called Ambition 2039, where they step by step lower the threshold for what kind of carbon footprint they allow in the materials that goes into their cars.
So this is like a supply, they're putting a self-regulation on their supply chain.
Correct. And many companies are doing the same thing. There is something called the First Movers Coalition, where large companies can join an initiative. And if you do that, you commit to that by 2030, at least 10% of the steel that you're using has to be this near zero emission type of steel products, where General Electric is a member, for example, Volvo is another, and so on. So that we can see that many companies, self-regulatory is one way of putting it. Many companies put their own corporate targets ahead, maybe, of political measures.
Okay, I want to go back to some of these. I actually want to talk about how a few of them are doing it in relation to SSAB. But I just wanted to, on the hybrid, the hydrogen, it gets thrown around quite a bit, but I know you were familiar, a lot of people watching will be familiar with it. But even myself, I don't quite understand the process of it. When you say you're using hydrogen power, is that like a plant that you set up at your facility, or is that like a shared? So how does it actually get powered? Like, where's the physical plant placed?
The way we are doing it is that we are producing the hydrogen close to our plant, and we do that by using electricity to split water molecules into hydrogen and oxygen. And then we expose the iron ore to hydrogen. And then the oxygen in the iron ore moves to hydrogen to replace that missing oxygen atom to become water again, pretty much. So, like I said, we're not really consuming water, we're borrowing it for a little while. We remove the oxygen that is there and we replace it with the oxygen that is in the iron ore, so that we get the oxygen out of the iron ore so that we're left with the iron. That is what we want to do.
Right. Now, sorry, did you have something to finish on that? I looked down. I didn't know if you were done yet. My apologies.
No, I can expand on that a bit more.
Yes, please.
What we're seeing, both in North America and in Europe and in many other places, is that we're getting an increasing amount of what we call variable renewable electricity sources, wind power, for example. And in many cases, we have situations where there is more electricity available than we can actually consume. And then what we can do is that we take that excess electricity, we produce hydrogen, and that is something that we can then store and use as it is needed in our own processes. And vice versa, when there is a lack of electricity in the system on a cold, dark winter night with no wind power, for example, we can stop using electricity to make hydrogen, but rather use hydrogen that we have already produced and stored. So that way, in the future, we can not only make steel without emissions, but we can also help balance the power network, so we can use all those renewable energy sources that we have to the full extent.
You're touching on something that I think is worth mentioning. If you watched, let's say, news, especially like U.S. Canadian news, it's like a big bicker fest over how to use energy and all this type of stuff. But do you think in the real world, the industrial world, I'll use an example. A university just came out with a study about electric cars. So people will sit there and have these long discussions about whether they're better and, they're heavier, so they're harder on the roads. And this is a big discussion. They did a very simple study. They studied across, it was Canada that they used. And they studied different locations and where it applied and where it didn't apply. And it became very easy. You could just look up and go, okay, in BC, if I have an electric car and I drive 40 kilometers a day, then it does make sense. If I drive 19 kilometers a day, it does not make sense. It's better to buy. So you could actually look through Canada and decide, based on your driving habits in a particular area, based on energy costs, fuel costs, what you should buy, what type of vehicle you should buy. So this big discussion has now been broken down in Canada. You can just go look and make an easy decision. Is it similar in the industry where I think from a consumer standpoint, we're looking at an industry that, are they using clean energy? Are they not? But has industry kind of figured out how to piece all of this together, do you think? Or are they very close to figuring it out? I know it's a very long-winded question, but I think it's an important one.
It is an important one, and I should be very clear on the fact that we are fortunate insofar that both in Sweden and Finland, where we have our iron ore-based operations, we have a virtually CO2-free power grid. We have clean electricity so that we can use electricity to make hydrogen without CO2 emissions. That's an important thing. If you don't have access to clean hydrogen, then this technology makes less sense, admittedly. On the other hand, I think we all agree that we need to have access to clean electricity sooner or later anyway. That's one of the challenges that we have in the world. And you can even say that if we could just have access to clean energy, clean electricity at a reasonable cost, we can get rid of most of the environmental issues that we have today. They are almost all related to burning fuels one way or the other. Now, when it comes to this access to electricity and how this makes sense, the Rocky Mountain Institute in the US made a report a couple of years ago where they said that, okay, if we implement this hydrogen-based technology in the global industry overnight, what would happen then? And the answer is that globally, that would be pretty much a zero-sum game. In Sweden, for us, we would reduce our CO2 emissions by 100% because we have clean electricity. In Europe as a whole, with the electricity system the way it looks, the CO2 emissions would be reduced by 30%. In China, the CO2 emissions would increase by 30%, depending on what the electricity system looked like over there. But again, I think it's safe to say that we need to address those electricity generation issues anyway.
Yeah, it's
wait for it to happen.
Yeah, and there is that urgency. Again, sorry, I'm taking you on a bit of a rabbit trail, but it's a good discussion. I think it ties in with what you're doing here. What I wanted to do is just sort of wrap up with you mentioned, you've just sort of touched on them quickly, but you mentioned Mercedes a little more in depth, but there's also Volvo. You mentioned Sandvik. Can you just sort of circle back on a couple of those and just sort of how they're approaching it in their supply chain and just some examples, just expanding on what you sort of touched on throughout the interview in relation directly to your products?
Absolutely. One of our first so-called fossil-free partners was the Volvo Group with heavy trucks and construction equipment. And together with Volvo, we actually have what we called a limited serial production. So some of the iron that is produced in our research facility, we do actually turn into steel that we deliver to Volvo for use in their electric truck lines. If you buy an electric heavy truck from Volvo today, you have reasonable odds to get fossil-free steel in the chassis beams. If you do that, you get a little letter from the Volvo CEO that says, "Dear customer, it's a very special truck that you have bought."
Oh, yeah. That's a nice touch.
Yeah, it is. And Volvo has also recently made a press release confirming that they are using our scrap-based product, the SSAB Zero product that we also have for our Hardox line, in the chassis for some of their diesel-powered trucks. So next year, approximately, if I remember correctly, 12,000 Volvo trucks will be made based on our SSAB Zero product.
Wow.
We're also working together with the Polestar company making electric cars. They have a project called Polestar Zero, which is all about putting a climate neutral vehicle on the market by 2030. So there we're working together to minimize the carbon footprint, or rather eliminate it. And there we're looking at replacing not only conventional steel with our emission-free steels, but also replacing aluminum, plastic, carbon fiber, and other materials with a higher carbon footprint than what our steels will have. And like I mentioned before, we know that Mercedes has their Ambition 2039 program, where they step by step reduces the threshold for what kind of carbon footprint they allow for the materials that they're using in their vehicles, not only for steel, but for all the different materials. And actually already next year, 2025, those demands are pretty tough to meet with conventional steel. So we can really see that many of the global companies drive the development of sustainable materials. And I think also...
Oh, sorry. Sometimes it's hard to, when I'm on a screen, sometimes it's hard to see when. Please continue.
And many listed companies have different kinds of sustainability objectives, sustainability targets, sustainability strategies that are communicated to investors, to analysts, to shareholders, and so on, that also drives this development forward. So there are many corporate initiatives that I think in many ways are ahead of political regulations or other type of legislative measures.
That's quite refreshing to hear, actually. That's what industry should be doing. You also mentioned Sandvik quickly. Can you just what is the relation with them in their supply chain?
Sandvik is another good example. They are also one of our fossil-free partners, and recently at the Mine Expo, they exhibited a box for an underground mine truck, which is made with our SSAB Zero, our scrap-based product made without emissions. And as I understand, that is now commercially available for customers to specify when they buy their new truck from Sandvik.
If we have any links or images to that, actually, you have it in a. There might even be a. No, I don't think I saw the Sandvik one on the case study. If you've got any links, I'll if you could send those, that would be great. We can bring them up on the screen. Last question before you go is, well, I say that sometimes and I add in a couple more, but getting towards the tail end, that's probably a more accurate way of saying it. You said this initiative started in 2016. What do you happen to have that insight? I just did a quick look on LinkedIn just to see how long you've been with SSAB 10 years. Is that right?
Correct.
Do you have any insight into, was this partially driven? Obviously, there's a lot of different factors. We don't need to get into every single one, but was this partially driven? Were companies like the Mercedes and the Sandviks, and were they already asking about this? Or did SSAB just sort of see this in the market, see the shifts, see the political landscape? Do you have any sort of insight onto some of the drivers coming from industry specifically?
I think in all fairness, this was very much our way of looking into what should a steel company actually look like in the future? Where is the world heading? Where do we want to be? And I think for us, it was very much a question of showcasing, taking the lead, show that steel, a hard to abate sector, actually can change. I think it was very much for us a way of positioning ourselves to be on the forefront and really show the world what can be done.
Yeah, it's quite incredible actually seeing these major industries and companies like SSAB actually making these shifts. And it's also it doesn't end up on the front page, if you will, of a lot of the news. That's why we do the show, because a lot of people don't realize what's happening sort of in these commodity markets, in the industrial sectors, and how much success is actually happening on that side. So Thomas, thank you very much for joining the show. I hope you enjoyed it. It was great talking to you. Thanks for letting me take you down a couple rabbit trails. Sometimes I just sense people have information about certain things, so I like to try to glean as much as I can in these interviews. So thank you for doing it. I hope we do it again.
Thank you so much.
And thank you everybody for watching. You can connect directly with Thomas. We'll have his LinkedIn in the description below. Of course, you can visit SSAB, visit their website, follow them on LinkedIn. All of that will be in the description below as well. Like I always forget to say at the beginning of the videos, also please subscribe to us, follow us, and recommend guests. As you can see, if you go onto our playlist, you'll see it is all across heavy industry people that we feature. So make sure to recommend them if they're in heavy industry or even in the professional service that provides the heavy industry. We want to have them on. So thank you everybody for your support. We will see you on the next episode of Mining Now.